Ever wondered why iterators are considered an essential part of C++ programming? Well, let's delve into that. Iterators play a crucial role in C++ programming by providing a mechanism to access elements in a container without exposing the underlying representation. This abstraction not only ensures a high level of data security, but also enables programmers to work with different data structures seamlessly. Moreover, iterators are instrumental in making the code more efficient, readable, and maintainable. They facilitate traversing through elements of different containers, such as arrays, lists, or maps, with ease and uniformity, regardless of their complexity. This uniformity in code structure significantly improves the readability and maintainability of your code, making it easier for other developers to understand and work with it. Furthermore, by making code execution more efficient, iterators contribute to the overall performance of your program. Thus, the significance of iterators in C++ is undeniable, forming the backbone of efficient code execution. Now you might ask, what exactly is an iterator in C++? Well, let's dive in and unravel this mystery. An iterator, in the simplest terms, is a tool that enables us to traverse through the elements of a container, whether it's an array, a vector, or a list. It's like a compass guiding us through the maze of data stored within these containers. But how does this work? The idea is rather intriguing. An iterator behaves much like a pointer. Just as a pointer points to a memory location, an iterator points to an element within a container. It's like a cursor moving through a text document, where each word is an element of our container. Now here's where it gets exciting. Iterators come in a variety of flavors, each with its own unique characteristics. Let's quickly run through them. First, we have the input iterators. They're like one-way streets, allowing you to move forward and read elements from the container. Then we have the output iterators, the mirror image of input iterators. They provide a way to write into the container. Next, we find the forward iterators, a step up from input iterators. They let you read and write, but only in one direction. It's like having a rewind button that doesn't work. Then come the bidirectional iterators. As the name suggests, these iterators allow you to move forwards and backwards, giving you the freedom to read and write in any direction. Finally, we have the random access iterators, the most powerful of them all. They're like teleportation devices, allowing you to jump directly to any element in the container, making your traversal faster and more efficient. In essence, iterators serve as a bridge between containers and algorithms, allowing them to work together seamlessly. It's like having a universal translator that enables different languages to communicate. With iterators, the possibilities are endless, so buckle up as we dive deeper into the fascinating world of iterators in our upcoming scenes. Beyond the basic iterator types, C++ also offers specialized iterators. Intriguing, isn't it? These specialized iterators are like the secret weapons of C++ programming. They cater to specific needs and provide enhanced functionality that can take your coding skills to the next level. Firstly, let's talk about reverse iterators. As the name suggests, these iterators are used for reverse traversal of containers. Imagine you're reading a book, but from back to front. It might sound strange in a literary context, but in C++, this reverse journey can be extremely useful in certain scenarios. With reverse iterators, you can navigate through your data structures in a backward motion, starting from the end and moving towards the beginning. Next on the list, we have move iterators. These iterators are quite the game changers. They allow for the transferring of ownership of resources. In simpler terms, they enable you to move elements from one container to another, rather than just copying them. This comes in handy when dealing with large data structures, as it can significantly improve performance and efficiency. Last, but certainly not least, are stream iterators. These iterators are all about input and output operations. Think of them as the gatekeepers of data traffic in your programs. Stream iterators can read data from an input stream or write data to an output stream. This makes them crucial for file handling and data processing tasks. To sum up, specialized iterators in C++ aren't just fancy extras. They are essential tools that cater to specific needs in your programming journey. They provide you with the flexibility to traverse containers in reverse, the power to move elements efficiently, and the capability to handle input and output operations seamlessly. Specialized iterators, therefore, enhance the functionality of C++ programming by catering to unique requirements. So, the next time you're coding in C++, remember these specialized iterators and watch how they revolutionize your programming experience. A concept is best understood with examples, so how about we explore some practical uses of iterators? Let's start with a basic example. Suppose we have a vector of integers and we want to display each element. We can declare an iterator using the auto keyword and the begin function, which returns an iterator pointing to the first element of the vector. Then we use a for loop to iterate over the vector, incrementing the iterator at each step until it equals end, which points 1 past the last element. Inside the loop, we use the dereference operator asterisk to access the value the iterator points to. Here, the iterator acts as a smart pointer, providing a way to traverse the vector. Now, let's spice things up a bit. Let's say we have a set of strings and we want to find a specific string. We can use a find function which returns an iterator pointing to the found element or end if the element is not found. We then compare this iterator with the end to check if the element was found. This is a great example of how iterators can be used for more complex tasks, like searching for elements. Let's move on to specialized iterators. Remember, these are designed to work with specific types of containers. For instance, let's take a look at back_inserter. This is a specialized iterator that works with containers supporting push_back function like vector or dec. Suppose we have two vectors and we want to append the elements of the second vector to the first. Instead of manually looping through the second vector and pushing each element to the first, we can use the copy function with back_inserter. This will create a new iterator that pushes elements to the back of the first vector, effectively appending the second vector. Finally, let's consider iStream_iterator and OStream_iterator, which are used for input and output streams. Suppose we want to read integers from the standard input and write them to the standard output. We can declare an isStream_iterator for sin and an OStream_iterator for quote. Then we use a copy function to read integers from the input and write them to the output. This is a powerful example of how iterators can simplify code dealing with I/O operations. In all these examples, iterators serve as a bridge, connecting algorithms and containers. They allow us to write generic code that works with different types of containers, making our programs more flexible and reusable. These examples should help solidify your understanding of how and when to use iterators in your C++ programs. Let's take a moment to revisit the key points we've covered about iterators in C++. We kicked off this journey by acknowledging the critical role of iterators in C++. They are more than just a bridge between containers and algorithms. They are the backbone that allows us to access and manipulate data in a container without exposing the underlying implementation. In essence, iterators are the workhorses that allow us to traverse through elements of a container, irrespective of its type. We then delved into the concept of iterators. We discovered that they are objects that, in many ways, behave like pointers. They point to elements within a container and provide a means to access and manipulate those elements. We also discussed the 5 types of iterators: input, output, forward, bidirectional, and random access. Each type has its unique properties and use cases, broadening the range of operations we can perform on our data. Our exploration took us deeper into the world of specialized iterators, a more advanced aspect of C++. We learned about reverse iterators that traverse a container in the opposite direction and move iterators that transfer ownership of elements. We also uncovered the unique capabilities of stream iterators for handling input and output streams, and insert iterators for adding elements to containers. These specialized iterators, though complex, offer flexibility and efficiency in handling more intricate data manipulations. We brought it all together with practical examples demonstrating how iterators can be used in real-world scenarios. From iterating through an array with a for loop to using an insert iterator to add elements to a vector, we saw the power of iterators in action. To wrap up, let's reiterate that iterators are an indispensable tool in C++. They provide a robust and efficient way to access and manipulate data, and with specialized iterators, we can handle complex data operations with ease and elegance. Remember, mastering iterators can significantly boost the efficiency and sophistication of your C++ programs. So keep practicing and experimenting with them.